All right, the other major issue with all of these components is they're spinning at a high rate of speed. Be thinking, wow, this is metal on metal contact. How in the world does it not just grind itself down to nothing in a relatively short time? And the reason is this. It's a piece of metal, and we precisely machine this piece of metal to precisely fit in the case of the engine and also fit along and interface exactly with our crankshaft. And you'll notice that this bearing has some holes in it, and these holes line up with the holes in our case, and they allow pressurized oil to enter into this bearing. And what happens ultimately is, as we're flying, this crank isn't making contact with metal. It's actually riding on a cushion of oil, a very thin cushion of oil. So ideally, a properly running engine with proper oil pressure has enough oil pressure where it actually is a liquid bearing almost. So this liquid bearing prevents metal on metal contact. And that liquid bearing is only made possible by oil pressure. So when you're checking oil pressure in your engine, what you're actually checking is the pressurization of these 3 locations in your engine case. If these 3 locations lose oil pressure at any time, that liquid barrier disappears and you start to have metal on metal contact. So if you ever lose oil pressure, you're looking at an impending failure pretty quickly, because what's going to happen is, as this crank spins, you can actually hear it sort of grinding on that bearing. Eventually, you're going to have a catastrophic failure where the engine will seize up completely. And if I don't know how it's been operated, if I don't know that it's actually experienced a loss of oil pressure, I may not know the internal conditions of these critical components until they actually fail. And when they fail, it's typically going to be in flight, and it's not going to be a very good day for you. So you really want to make sure you're watching that oil pressure at all times. So bring that oil pressure into your scan.